because all these artifacts and stuff like that are intangible in contrast to all the electric currents or metal beams you deal with in civil engineering or mechanical engineering. And so we are trying to get up to speed with regard to the traditional engineering to fix those foundations in this respect. And in addition, lots of the foundations which we have in traditional engineering is based on ordinary differential equations and stuff like that. And all the aspects which we have to express in software engineering are difficult to express in terms of differential equations. So we need another foundation there as well. Many believe that is logic and maybe even non-traditional forms of logic which we need there. And this hasn't been mentioned today, that there is also another activity going on, or starting slowly and coming up with, that we also develop a foundational theory for that as well. But we don't want to threaten people by talking about logic and non-traditional forms of logic in this respect that we can get these foundations as well. But let me mention that we are looking into these aspects as well and get there just on the one side a mathematical foundation in this sense, but also we look at people and how people behave. So there's a kind of work emerging from software engineering which deals with empirical software engineering, and get also a grip on that we execute those processes and want to find out how efficient those processes work. So we also address the empirical side of it, how these processes actually will be efficient or not efficient. So we get feedback on that, how good our practices are, or whether we have to invent new practices or tune them to find out more better ways to deal with the problems in software engineering. So that's my comment on that. And Ian?
I'd like to make a comment. I think both your statements really are correct. I mean, software engineering is a very young industry, and we're still learning what works. Okay, and we don't have a solid foundation. People still call things lots of different things. As an engineering discipline, compared to the others, software engineering is very unprofessional. There's none of the liabilities you get in other engineering. And if your buildings fall down and your chemicals explode, there's liabilities if your software falls down. It's just software, isn't it?
Just a bug.
It's never very reliable. So we need to, over time, you'd expect software engineering to become more professional and have more of those attributes of other engineering disciplines. But the other thing you said is software engineering is different, as Michael was saying. You don't have the same economies of scale, you don't have the same binding of resources. But because we're a young industry, we're always comparing ourselves to other people. Now I'm hoping with things like SEMAT we can start to do things that other disciplines will learn from us. Okay, software is going to be the future, it's going to be more important than anything else. And we've got to stop saying, oh, we're like manufacturing. No, we're not. It's not like manufacturing. It's not like chemical reactions. But the professionalism and those things are things we need as an industry to make it a profession. And hopefully this kind of activity can get us towards that. You know, but it is an incredibly young industry. Although not all of us are young.
And only me.
Young at heart.
Any more questions?
I
sorry.
have a brief response to that. SEMAT was formed to solve some problems that are very specific to software development, but you know, we've even in our discussions have had some hints that some of the ideas we come up with are applicable to processes in other areas. So you could look at, for example, general project management processes, or you know, if you look at some of the process definition work that we've done at IBM, we've had automotive companies come to us and they want to capture the processes for creating automobiles with our process tools. So SEMAT is trying to address some very specific problems, specific to software development, but there is the potential that some of what we're doing is applicable elsewhere.
Okay. Any more questions?
We like that kind of questions, by the way.
Okay. If there are no questions, then let me thank you for coming here. And let me thank you, my SEMAT colleagues, for coming to Sweden and present our latest work and results. And I hope to see you in the future. By the way, I hope you have also signed the list with your name and email so that we may contact you in case you might be interested in getting in touch with us or in collaborating with us or for some other reason.
And if you are not yet a supporter of SEMAT, there is something for you to do.
So, okay, thank you very much.
Thank you.
Ah,